And let's talk about the mole. So, the mole is kind of how we count matter in chemistry. And so sometimes we count things using mass or volume, but now we're going to start using the mole. So chemistry is a quantitative science. You're going to need your calculator every day this week and after spring break. You will be calculating various quantities, and we're going to talk about how to solve those problems over several days. So if we talk about apples, when I use Instacart, I order by the apple, but if I were to go myself, I would probably do it by pounds. But you could do it by mass, you could do it by weight, or you could do it even by volume. So each of the following different ways, if I do it by count, I have a dozen apples. That means I'm wanting 12 apples. If one apple equals 2.0, or a dozen apples equals 2.0 kilograms, then I could convert. And I can also use a conversion factor that a dozen apples equals 0.20 bushels of apples. And so I can arrange these in various ways to calculate other things without actually having measured them. So if I know I have a dozen apples, I can write that as either 1 dozen apples over 12 apples, or I could write 12 apples over a dozen. And so any conversion factor you can write can be written in two ways. And so you have to make sure that your units cancel. You're going to have to write not only the substance, but a quantity or a unit that's with it, and then also a substance. So what is the mass of 90 average size apples if a dozen apples has a mass of 2.0 kilograms? So what you're given in this problem is 90 apples. Your conversion factor is 1 dozen apples equals 1 kilogram of apples. And so you could write those conversions one of two ways. And now what you want to find is what is the mass of 90 apples. So you always start with the conversion. You're always going to, and this needs to appear in your notes, you're always going to have to use a conversion factor, and the final thing in your conversion should be what you're looking to find. And you also have to make sure that those units cancel. And so one is above the line, then the other is below the line. Those can cancel. So, and we're going to do this conversion in class, so please remind me. What is a mole? Well, chemists use moles to tell us the amount of substance that's present. And so all chemical equations are written in moles. So particles are much smaller than grains of sand, and so it's extremely large number of molecules or atoms would be in a substance. And so counting particles one by one is just not possible or practical. And so we either use mass or moles. So if you go to the grocery store, you can buy eggs by 24s or 18s, and typically you buy a dozen. You can also do the same thing with donuts, which is much more fun. But you can also buy individual donuts at a donut store, as my granddaughter calls it. But at the grocery store, you couldn't buy an individual egg. You would have to buy a dozen, or half dozen, or 18. So we are going to use the mole as our unit of a substance, and that's going to be Avogadro's number of representative particles, 6.022 times 10 to the 23rd, and that is our SI unit for measuring the amount of a substance. Term representative particle could be something like an atom. It could be a molecule. It could be a formula unit. It could be an ion. It could be almost anything. And so if we're talking about iron, we'll be talking about iron atoms. If we're talking about helium, it would be atoms. If we're talking about oxygen, it would be O2, and it would be molecules. There are 7 diatomic elements. This is the second thing I want to see in your notes for tomorrow. And you have to have them written down and highlighted. And these are the representative particles for these would be molecules. Anything like water would also be a molecule, but those 7 you need to know. For the ionic compounds such as calcium chloride, the representative particle is called a formula unit. You'll probably hear me call it a molecule. It really doesn't matter. I'm not going to be particular on this. The mole allows chemists to count the number of representative particles because the mole of anything is 6.022 times 10 to the 23rd particles. So here's a table. Obviously, there's various things like ions or atoms or molecules, but they're all the same number. And here's a couple of funny memes I had. I asked you to bring me a meme, and so here are mine. You might want to pause and look at them. So if we are converting between particles and moles, we use this equivalence or this conversion unit, and we can write it one of two ways. So magnesium is a lightweight metal used in the manufacture of aircraft, automobile wheels, and tools. How many moles of magnesium is 1.25 times 10 to the 23rd atoms of magnesium? And so we have to figure out what we're given. We have a conversion factor, which is going to be 1 mole of magnesium atom equals 6.022 times 10 to the 23rd particles. And so that's our conversion factor. We're going to line it up in such a way that we end up with what we're looking to find. It needs to be in the top. And then we make sure that our units cancel. So atoms of magnesium cancel, and we come out with 0.208 moles of magnesium. And again, you need to remember your significant figures come from your data, not from your conversion factors. So one does not simply do stoichiometry without converting to moles. We're going to do a lot of conversion to moles. So suppose you wanted to determine how many atoms are in a mole of compound. Well, then you would use the same conversion factor. You're just going to go the different direction. So the formula of carbon dioxide is CO2, and the subscript tells me in 1 molecule of carbon dioxide, there's 3 atoms total. 1 is carbon and 2 are oxygen. So 1 mole of carbon dioxide contains Avogadro's number of CO2, and each molecule has 3 atoms. And so we have a total of 3 moles of atoms. To find the number of atoms in a given number of moles of a compound, you must first determine the number of representative particles. And so we use Avogadro's number and we would multiply. I really strongly urge you not to learn to multiply or divide by something. You really should learn to make those units cancel, and then it'll always work. So propane, and this is the last question for today. Propane is gas used in cooking and heating. How many atoms are in 2.12 moles of propane? So we, of course, will start with what we're given. Our conversion factor is 1 mole equals 6.022 times 10 to the 23rd molecules of propane. And 1 molecule of propane has 11 atoms, 3 plus 8. So we want to know how many atoms. So we start with what we're given, and we multiply by Avogadro's number, and then we multiply by the atoms, and we get 1.4 times 10 to the 23rd. And I think there's a problem there, but we will work that one out in class as well. Okay, thanks for listening. You'll have one more video.